Now, let us consider the remaining part of the projectile case. From the previous case, we have an equation for tan theta into x minus g by 2u square cos square theta into x square. This is the equation of projectile y, whatever we have. Now, the value of y you can prepare in the form of standardly ax minus bx square. We can write down like this, known as this particular equation in mathematics known as what? Parabola. So therefore, when you try to project an object at an angle less than 90 degrees but greater than 0 degrees, then the object will try to choose a kind of path known as parabola. Okay, this is the case what we have to remember. Now, further what we have to remember here, let us see one by one. First one, what is initial velocity actually? Initial velocity u bar is equal to, you can write down as uxi plus uyj, because the initial velocity can be resolved into components. Now, this can be further prepared as u cos theta of I plus u sin theta of j, we can write down. Therefore, initial angle of projection theta is equal to tan inverse of uy by ux with a modulo symbol, so you have to write down like this. Second, at a particular time, for example, this is the projectile and this is the trajectory what we are taking. Now here this is our observation point. At this particular place, upon again preparing the velocity vector, this is the velocity vector, this is the horizontal to that of one base we are considering here, and here angle is alpha. Okay, this is called Vx and this is called what? Vy. So at that particular point P, we have the final velocity vector V bar is equal to, we can write down as Vxi plus we can write down as Vyj. Further, you can write down as what, since horizontal component is remain same, it won't change. Therefore, you can write down as what, Uxi plus Uy minus Gtj we can write down. Or in other sense, we can write down with another kind of model form, that is Uxi plus root of Uy square minus 2Gy of j cap. That means we can use any one of the equation, either above or below, any one of the equation we can use. And the angle at the particular time given by tan alpha is equal to Vy by, you can write down as Vx. What do you mean by Vy in the problem? Vy means you can write down as Uy minus Gt by Ux, you have to write down. So therefore you can write down as what here? Uy by Ux, Uy by Ux minus Gt we can write down. That means tan alpha is equal to by Ux you can write down. So here you can write down as Uy by Uy by X means what? Tan theta. Therefore you can write down as tan theta minus, you can write down as Gt by Ux. We can write down like this. Now, upon exchanging parameters, you can find the value of what? Time of journey. When angles are given means you can find the time of journey. So depending on the problem, we have to take care of the particular question. So this is the point number 2. Now, however, suppose if they will ask you a question that what is the speed of that particular particle at that particular time. So we have to calculate the speed. How to calculate speed here? The speed of the projectile V is given by root of, we can write down as x square component plus y square component we have to write down. So root of, simply we can write down as vx square plus vy square, means you can write down as ux square plus uy square minus 2gy we can write down. And upon solving this, ux square plus uy square nothing but what, speed u only na? Therefore the speed of the particle v is equal to root of u square minus 2gy we have to use whenever height y is given in the problem. Now let us consider the next case, point number 3. Suppose if initial velocity vector perpendicular to the final velocity vector at a particular observation position, then how can we imagine this particular situation? This is the exactly the projectile what we are considering track, and this is the initial velocity vector u bar, and this is the final velocity vector v bar. So this is our observation point. Here the velocity vector v bar is perpendicular to that of initial velocity vector u bar. Now what is the time of journey from here to here, 0 to here? What is the total time of journey? Suppose they will ask. Then let us try to find. Whenever two perpendicular vectors are there, means their dot product no doubt becomes what? 0. Already we know this one from the vectors concept. So therefore, in this particular case, let us try to substitute the values of u bar and v bar. Upon writing here, you can write down as u cos theta of I plus u sin theta of j dot u cos theta of I plus u sin theta minus gt of j is equal to 0. This is the case. Now let us try to do I dot I. I dot I means what? 1. Therefore u square cos square theta plus upon multiplying this u square sin square theta minus u sin theta into gt. This is the thing what we write down in the given case is equal to what we write down 0. Now u square minus you can write down as u sin theta into gt is equal to 0, and we need to find out the value of t. Upon solving, we have the value of t is equal to u by g sin theta. So therefore, at this particular time, what happens? Initial velocity vector and final velocity vector after completion of t seconds, they are going to be perpendicular with each other. What is the remaining time to reach the ground develops? Remaining time. So here only fourth point. Remain time. Remaining time, or how much? So remaining time delta t is equal to t minus small t we have to do. That is nothing but 2u sin theta by g minus u by g sin theta is the remaining time. So in the given case, you can make what is common in the equation u by g common. You can make u by g common. As a result, you can write down as 2 sin theta minus 1 by sin theta. We can write down. Upon solving further, you will get some trigonometrical equations, and solving you will get the final required answer. Next.